now we're applying what we learned yesterday, just a couple of things. Remember, something that makes it similar has the same, hello? Yeah, same angles, which gives it the same shape, but different sides, which means the sides are proportional. Hello, we remember. All right, given that the triangles are similar, find the lengths of the unknown sides. Find the lengths of the unknown sides. So it's really important to match up the sides. This is the proportional parts, right? We have one set of sides. We have the 8, which matches up to the 12 on this triangle. Notice there's a 12 on both triangles, but go ahead and circle those things. That will be your common ratio, and that's how you're going to find the other sides. When you set up ratios, make sure you set it up in a uniform manner. So if we're going to go small triangle to big triangle, then make sure you keep it that way. If you go big triangle, small triangle, make sure you keep it that way when you set up your equations. So let's go ahead and go small to big. All right, so we know that we have a ratio of 8 to 12 on one side. Okay, let's find the other side. So PN has a 12, and that relates to side, which side? RS, yeah. So we're looking for RS. The 12 matches up to this RS, right? We're going from small big, cross multiply. So 8 RS is equal to 144. Yep, 144. That means RS has a measure of, what is it? 18. Yeah, so this is 18. Okay. Now, because this is a found side, there may or may not have been a math error. Some folks might have switched it around. So you're really not 100% sure about this answer. But you are 100% sure about what's given, right? So to find the next one, still use what is given. We're going to still use the 8 over 12. At this time, we're going to find the missing side at the bottom. So going small to big, it's 10 over side QS. Thanks, Josh. Here we go. Cross multiply, 8QS is equal to 120. So therefore, side QS has to be 15. Yay! Which doesn't make a whole lot of sense because that sure looks a lot, well, I don't know, maybe. I don't know. But it actually looked at it. So the smallest side is the smallest side. The next smallest side is the next smallest side. And the largest side is the largest side. Right? It can make sense. Right. Okay. Here we go. What? Jewish? Did you say word problem? All right. Sam wants to know the height of a tree in a park of his nearest home. Okay. So there's this tree. I promise you I'm not an artist, although I do like to paint. Here we go. The tree, thank you. The tree casts a shadow. Ooh, I'm even doing the leaves. Ooh, right. The shadow is 38 feet tall. Right? Yes. Sam, I am, is right here. He is my height, 62 inches, right? And his shadow is 42 inches. We're looking for the tree. What's up? I look like an ice cream cone?
No, my tree does.
Your tree looks like an ice cream cone. Okay. Talk to me. I like it. Talk to me. Go ahead, Angelina. No, you were saying something, weren't you? Is it Logan? Angelina. Talk to me. Okay. You went small to big. Well, small figure versus the big figure. There it is. Yeah, here we go. So you got to go 42 is to 38. Did anyone set it up a different way? Yes, Miss Star. Yes. 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 Does it matter in this case? That's the question. All right, so let's try it. Let's try it, okay? This is good. This is good. Does it matter if one of them is in feet and the other is in inches? Notice, though, that they have both feet here, okay, and both inches here. Right now, Ms. Angelina did not change the units, yay? So let's solve it and see what we get without changing units. Changing units. Okay, without changing the units, you just cross multiply. So you get 42x equals, you guys have calculators, I don't. What is it? 23, 30, 56. That's a 5. Okay. Divided by 42 is 56.09-ish. So it's about 56 feet. Okay, so ask yourself first, is that a reasonable answer? So, like, if you take a look at it, both cases, the shadow is smaller than the actual object. True? The shadow is smaller. So this is definitely bigger than 38. So is that a reasonable answer? If you do want to keep the units, and you have plenty of space there, let's go ahead and ponder this right now, all right? If you want to change the feet to inches, let's see if it matters if you change the units. So how many inches are in a foot? 12. So 38 is also how many inches? 156 inches. 400. Thank you, Donnie. There we go. It's also 456 inches. So using everything but changing the 38 to 456, let's see if it's the same thing. All right. So you have 62 over x is equal to 42 over 456. This is changing to inches. Units to inches. What do you think? 42x is equal to, oh boy. Give it to me one number at a time.
6, 7, 3,
Uh-huh.
0.14.
No, sorry. 62 times 456. My bad.
20,000.
Ah.
272.
Okay. So, pen. 2, 8.
No. Yeah. 282.
2,
17.
7, 2. And Donnie had the final answer of
6, 7, 3,
7,
0.14.
3. So 0.14 inches, right? Okay. Converting that to feet, just divide by 12. What is it when you convert it to feet? About 56 inches. So, always good to ask that question. Do the units matter? But always use your judgment as well to see if, in this case, since the units were the same for each piece, then that's fine. If the units were different, like the tree was in foot but the shadow was in inches, you're going to have to, make it so. Yay? Okay, here we go. You have two types of assignments. One is the classwork. The other one is your homework. All right? For your classwork, you can use the back side of your, okay.